Today we're going to do lesson 3.2 where we're solving linear systems algebraically. There are two different methods we're going to discuss today. The first is substitution and the second is elimination. First we're going to tackle substitution. In substitution, you will have a system of linear equations that have two variables usually x and y. The steps I've outlined are that first we're going to solve one of the equations for one of its variables. After we complete that step, we're going to substitute the expression from step 1 into the other equation and solve for the remaining variable. The next step is to substitute the value from step 3 into the revised equation from step 1 and solve. Our last step is to put our solutions into an ordered pair. Let's take a look at our first example. In our first example, I have the system 2x plus 5y equals negative 5, and x plus 3y equals 3. So in my first step, let's color code this. So my first step I'll do in yellow. I need to choose a variable to solve for. I usually like to choose a variable that's easy to isolate, and usually that means it has a coefficient of 1. So I'm noticing that this x right here has a coefficient of 1 and will be easy to isolate. All I need to do is move the 3y to the other side of the equation. So I will subtract 3y from both sides, leaving me with x equals 3 minus 3y. So step 1 is complete. Step 2, let's do that one in green. What I'll need to do then is I need to take this expression for x, where x is equal to 3 minus 3y, and substitute 3 minus 3y in for x in my other equation. So I will have 2 times x, which is now going to be replaced with 3 minus 3y, plus 5y equals negative 5. Once you have that equation all substituted in, make sure and double check that you only have one variable. Notice all the x's are gone in my equation and I only have y's, and it's time to solve for y. So I'm going to use the distributive property to distribute this 2. So I'll have 2 times 3 is 6, and then 2 times negative 3y gives me a minus 6y, plus a 5y equals negative 5. Next, I'll combine like terms, so I'll have 6 minus a y equals negative 5. Then I need to subtract the 6 from both sides, so I have negative y equals negative 11, which means when I divide by negative 1 to get that y alone and get that negative 1 away, I have y equals 11. So now I have step 2 complete. Then let's do our third step. I'll do that in blue. We need to substitute what I got for y into my revised equation back from step 1. So I'm going to have x equals 3 minus 3 times y, but I now know that y is equal to 11. So I have x equals 3 minus 3 times 11, which is 33. So x is equal to negative 30. And then my final step, you can do this one in red. I need to write my solution as an ordered pair. So my x value comes first, which is negative 30, and then my y value comes next, which is 11. And that is the solution to the system of linear equations. So now I know that if I were to graph these two equations, they would intersect at the point negative 30, 11. Let's look at another example. In my next system, I have 4x plus 3y equals negative 2, and x plus 5y equals negative 9. So here I'm taking a look at all of my variables, and in this equation it looks like this x will be the easiest to get by itself again. So to get x by itself, I'm going to subtract 5y from both sides, leaving me with x equals negative 9 minus a 5y. Next, what I need to do is I need to take this expression for x and plug it into x in the other equation. So when I do that, I'll have 4 times x, which I'm going to replace with negative 9 minus 5y, plus a 3y equals negative 2. And now I'm going to solve for y. So when I distribute my 4 here, I'll have negative 36 minus 20y plus 3y equals negative 2. Then I can combine my like terms here. So I have negative 36 minus 17y equals negative 2. I need to add the 36 to the other side. So I have negative 17y equals a 34. And then when I divide by negative 17, I get a nice solution of y equals negative 2. My next step is to plug this y back into my revised equation from step 1 and solve for x. So I have x equals negative 9 minus 5 times y, which is a negative 2. So x equals negative 9 plus a 10, and therefore x is equal to 1. Now I need to write my solution as an ordered pair, giving me 1, negative 2. So that is substitution. So again, to go through the steps one more time, you're going to solve one of the equations for one of its variables. Once you do that, you are going to substitute that expression from step 1 into the other equation and solve for the remaining variable. Then you will substitute the value from step 2 into your revised equation from step 1 and solve. And then last, you put your solution into an ordered pair. Let's take a look at another algebraic method called elimination. Sometimes this is called linear combination. So in your first step, you're going to multiply one or both of the equations by a scalar constant to obtain coefficients that are opposites. Coefficients are opposites if they differ only in sign for one of the variables, and sometimes you get to skip this step. The second step is you add the revised equations from step 1. If done correctly, combining like terms will eliminate one of the variables. Then you can solve for the remaining variable. Your last step is to substitute the value obtained in step 1 into either the original equations or the modified equations and solve for the other variable. Let's take a look at an example. So we have a system where we have 3x minus 7y equals 10 and 6x minus 8y equals 8. So what I'm focusing on first are the coefficients. Oops, I didn't want to do that. I wanted to highlight it. Okay, so let's highlight my coefficients for my x and the coefficients for the y. So we want the coefficients to be opposites. So I would need, if I'm going to eliminate the x, to turn the 3 into a 6 or a 6 into a 3, and then I need to make sure they're opposite sign. Or in this green, I want to turn the 7 into an 8 or an 8 into a 7, or I can multiply by something for both of them that would make them the same. So I might multiply the top equation by an 8 and the bottom equation by a 7 to get them to both be a 56. But the easiest method, it looks like the easiest way, is going to be to eliminate the x value here. If I multiply this top equation by a negative 2, remember you have to multiply everything, this equation turns into negative 6x plus a 14y equals a negative 20. Then I'm not going to change the second equation. And notice that by multiplying by a scalar constant of negative 2 on the top equation, I have now changed the coefficient of the x into a 6. My next step is going to be to add these two equations together. So when I add them together, negative 6x plus a 6x canceled to become a 0. 14 plus a negative 8y gives you a 6y. And negative 20 plus an 8 gives me a negative 12. So now I can solve for y by dividing both sides by 6. So I have y equals a negative 2. In my next step, I need to plug in y equals negative 2 to any of the equations. And in this step, I usually just pick whichever equation has the smallest numbers. So I think I'm going to go with this original equation right here, the 3x minus 7y equals 10. And I'm going to plug y equals negative 2 into this equation and solve for x. So I'll have 3x minus 7 times y, which I know is negative 2 now, equals 10. So I'll have 3x plus 14 equals 10. And now I need to subtract the 14 from both sides. So I have 3x equals a negative 4. And then divide by 3. So x is equal to negative 4/3. Once I know both my x and my y, I can write my answer as an ordered pair. So this ordered pair represents the point that these two lines would intersect when they're graphed, negative 4/3, negative 2. We have one more example that I'd like to go over before this lesson is done. So I have two equations, 3x minus 6y equals 9, and negative 4x plus 7y equals a negative 16. So here I have to decide if I'm going to eliminate the x's or the y's. So I'm taking a look again at the coefficients for x, and I notice that they do have opposite signs, and then the coefficients for y, and these also have opposite signs. So what I need to do now is make a decision on how I'm going to get those to be opposites by having the same number, the same coefficient, but still be opposite sides. So there's no way to multiply the 3 by anything to make it turn into a 4 or vice versa. And there's no way to multiply the 6 by anything to make it turn into a 7 or vice versa. So it looks like I'm going to be stuck multiplying both equations this time. So when I'm looking at 3 and 4, the least common multiple of 3 and 4 is a 12. And when I look at 6 and 7, it looks like the least common multiple there, it might be a 42. Might be smaller, but I'm thinking 42. So I think I'm going to go ahead and cancel those x's by turning the 3 and the negative 4 into a 12 and negative 12. So I'm going to multiply the top equation by 4. This will turn that first term into a 12x. And I'm going to multiply the second equation by a 3. I don't have to multiply by a negative because they're already different signs. So let's go through and do the top equation first. Let me adjust this a little bit so I have a little more space. Okay. So the top equation, when I multiply this 4 through, I'll have a 12x minus a 24y equals 36. And the bottom equation, when I multiply the 3 through, I get a negative 12x plus 7, 14, 21y equals 3 times 16 is, 30 plus 18, so negative 48. My next step, I'm going to add these two equations together. So I'll have 12x plus a negative 12x, which cancels. Then I have negative 24y plus 21y, which is a negative 3y. And then I have a 36 minus a 48, which is going to give me a negative 12. And now I can solve for y by dividing by negative 3, giving me y equals 4. Next, I'm going to plug y equals 4 into any of the original equations. You can even plug it into the modified equations if you want, but those are all pretty big numbers, so I think I'm going to stick with plugging it in just to this top original equation. So I'll have 3 times x minus 6 times y, which I just found was 4, equals a 9. So now when I solve this equation, I have 3x minus 24 equals 9. Then I need to add 24 to both sides. So I have 3x equals a 33. And then I can divide by 3 to get x equals 11. My final step is to write my answer as an ordered pair. So I have 11, 4. I hope that you have found this review of substitution and elimination helpful, and we will continue to build on these concepts as we build on our prior knowledge and learn new material throughout this year.